All right, so once again, welcome everyone to our fourth session of Design Pattern Study Group. I would like to welcome and introduce our wonderful speaker today, Poulami. Poulami is a senior software engineer at Delivery Hero who started her career in full stack roles, but transitioned over the last 5 years and became a front-end specialist. And beyond her professional work, Poulami is also a tech blogger and enjoys spending time with her toddler and has a passion for food. So thank you very much for presenting today, Poulami, and you can take it away. I'll stop sharing.
Thank you, Lexi. It was wonderful introduction. I will start sharing now. Okay. So welcome you all and once again in the JavaScript design pattern part 4, or rather the last session. We are really having a nice journey so far with two speakers already who has been covering the other 3 sessions, and let's begin without any further ado. So in today's session, we will be covering 4 design patterns, specifically that focuses into React's unique instance and code reusability. So we all know that design pattern actually brings a pattern in the code that we write, especially over here, we are dealing with JavaScript as we are working on the front end. So in any language, irrespective of its type and nature, the main purpose of design pattern is to bring a certain pattern into it, which helps in the maintainability, readability, sustainability of this entire code base. And in today's session, we will be focusing on the ones that we can follow to make our code reusable so that we can write less amount of code and can reuse the code as per our usage. So the ones we will be talking about includes the singleton, mixin, provider, and static import. So in all these 4, I will try to cover the examples in JavaScript, and also if it is relevant in React, I will try to show a React example as well of how we can use it in our daily life day. So in singleton pattern, the core principle of this pattern is like it ensures that a class has only one instance throughout the entire application. Now, over here, the word usage of the word class is a bit generic. We all know in JavaScript, we can write everything in functional programming. So mandatorily, we don't need to write a class all the time, but still it gives the concept that whatever we are doing, we should always be having a single instance of this entire application at a time. And that should also provide us a global point of access to that instance. It shouldn't be something totally encapsulated, but it should have some public endpoints as well. And the main reason why we need to go through this type of design patterns of having a single instance is like when we need to have a strict control over the resource usage. So we cannot have multiple database connection pools in our application. In that scenario, what will happen? Database will try getting updated from different instances differently, and then we will be having a very mismatch of data getting created in the database. So to keep it simple, we should always follow a single database connection pool so that we know if there is any database connection that is happening at this point, if certain table is getting updated or not, this thing. Also, there is another need, a single point of coordination for a specific task. Imagine you have a Sentry or New Relic or any sort of these type of logging tools. So we should follow a single instance of that logging tool. We don't need to create multiple instances of that logging tool in each of our file, so that it will create more code and then it will be very difficult to maintain. Also, scenarios like global configurations. For imagine you have set up dark mode in your Facebook account. So you always want to keep it dark. It's not that every time you refresh, you get the lighter mode and again you need to set it to dark. So user should be, these are the global configurations that we have. Like, okay, fine, the user has decided to make it dark. So let's keep it dark for the time being. Also, one thing that we need to take care when we are doing this design principle things is like it doesn't give you a full solution. It actually gives you a suggestion, an idea which we need to implement in our code base accordingly when we want to reuse this code. So a similar thing, an analogy that we can create with React also when we are talking about the singleton pattern is the global state management tool that normally we use third-party libraries like Redux, Justand, or something that React itself provide, the React context. So what they does is like they hold the global state during the application runtime, and it acts as the single source of truth for us. It always not only be in a read-only state. We can write pure JavaScript functions to update those, which we call reducers, to update those React context values. But again, if we see it as a whole, it always provides a single instance, and that is what we share across multiple components in React. So before going to the downsides, I will try to show an example. Um, I think my code sandbox is now visible. Yes. Okay. Thank you, Anna. So let's start with a very simple example of this singleton pattern. I have two examples, so I will just try to show the one that is a more bit easier to understand when we are going through the concept first. So, okay. So as before I mentioned that we should have a class that will have a single instance. So over here, I have created a singleton class. And in this singleton class, when an instance of this class gets created, the first thing we check is like if an instance of this singleton class exists or not. This is not something I have written. It's provided by JavaScript that checks whether there is an instance of a particular class or not during runtime. And if it is there, then what we do, we return that the instance that is already created. And if not, then whatever the current instance that we have created when we have instantiated it with the new, that this gets assigned in the variable singleton.instance. This is a static variable. And then what we do is like, imagine we have a property called data in this particular class, and I am setting the value as I am the one and only one instance that got created. In this class, I have a public method called getData, and this method returns the value of my current data property. So now if we look into our console, over here, I have created the first instance of this singleton class, and I have logged the content, the response from this getData method. And what I have got over here is I am the one and only one instance, as we can see it over here. So this is fine. Now let me create another instance and see what happens. So if I rerun the code, I can see I have two entries for I am the one and only one instance, because I have called the get data from instance 2 as well, which has also returned me the same value that we have got earlier. That is the one we have set. Now this is a primitive value, it's a string value. So if it is a string, then it doesn't ensure like it is the same instance or not. What I have done over here is like now I will be checking if the instance 1 and instance 2 is identical or not. And over here it returns true, which means it's an object and the instance of both the objects are identical. That's why. Now in the last part, what I will try to do is like I will try to update the data from instance 1. And what I should get the same data in my second instance also, because because it's a single instance that's getting shared across all the objects, all the instances that all the places that it got created. So over here, once I'm changing the data from instance 1, I will try to ensure that it's there in the other one as well. And if I rerun, and you can see like when I'm calling a get data method from instance 2, I am saying that yes, the data has been changed. Now this is a very basic example. In our everyday day-to-day life, the code that we write, we normally don't use these type of simple code. But this is the one to explain what this actual the concept is of singleton pattern. And now I will try to come up with something that there's a possibility we will be using these type of scenarios multiple times. So over here, What I have tried to set up is a configuration manager. So the same that I mentioned in my last slide about the global configuration managers that we maintain. So over here, I have written an immediately invoked function expression, or IFI, the one that we talk about. So what happens whenever this file gets loaded, this function gets called. So whatever is the content between this particular brackets or braces, it gets called. So now I will go through the code line by line. So over here in this configuration manager, so imagine you have an application where this file has got executed. That means you have got your configuration manager set up with some default values. And now we need to ensure that configuration manager values are identical across the application wherever you need it. So I have two very private variables. So first is the instance that I have set up over here, and second is some settings. So the default I have set, like my theme will be dark, my language will be English, and I have a set up an API endpoint at the same time. So now when this IFI gets called, it returns a public method called getInstance. So getInstance, what it does, like whenever someone is calling this method, it returns set of some functions. So how we are getting it. So first I'm checking if I already have an instance over here. If I have that instance, I will return it the same instance. And if I don't have an instance, I will create an instance. And once I create an instance, I will be returning a set or an object that has 4 public methods. So I'm opening 4 public methods of that particular instance, and at all points of time, it should be the same 4 public methods. And even the value that will be returned from that public methods will also remains the same across. So what are those 4 public methods? One is get settings, so which will actually return me, like if I say ask at any point of time what is my current theme, it will return me dark. If I want to set a setting, like okay, I want to make it a light setting, I will send the key and the value, and I will try to replace the settings object, modify the settings object actually. If I want to get all the settings at once, I have created a new object out of this setting, so that I need to ensure that user doesn't change the actual settings mistakenly. And then is the last one, where if I set total, try to modify with the total new settings, I want to initialize it. Then what happens, like if I take a new settings as a parameter, over here I have done a very basic check, like I'm just checking if it is an object or not. And if it is an object, then I'm trying to assign it to the actual settings that I have in this instance. And then these are the 4 public methods. So now let's go through the code, and I will try to show like how this is a functional programming. Over here, we have no longer used class, and we will try to see how this instance is identical. So over here, we have created the first instance, which I have named as configuration 1. And I have logged the default configuration theme and the default configuration language. So which was actually set by me at the beginning of the code. So over here, what I will be doing is like I will try to create a second instance of it. And once a second instance gets created, I will also try to check if both the first and the second instances are identical or not. And over here, as you can see, it got executed. Yes, it's true. So over here again, with instance, it means the set of 4 methods that we have written. So over here, you can see it's again an object. So we are making a check on whether the 2 objects are identical or not, and it says that it's the only same instance. So now what we have been doing over here is like we will be modifying the instance settings via instance 1. So what I have tried to do over here is like with configuration 1, I have updated the theme with the set setting method. With configuration 1, I have also added a new settings which says the debug mode, and I am setting it to true. And what my expectation is, like I will be getting the same value from my configuration 2 as well. So over here you can see like, yes, I have modified the setting theme updated to light, and the debug mode has been updated to true. And over here, as you can see, that configuration 2 is also having the light mode, and the debug mode is also being set in configuration 2. So now one more method that I have over here is like get all the settings, and I have tried to make a check over here as well. So what I have done is like configuration 2.get all settings, whatever the value I have received from my instance, I have put it into all settings, copy a variable, and I have changed the language. And now over here, language after getting modified, it says still English. This is what I mentioned earlier, like we need to ensure that if we say return the same instance that and someone changes over here, the value will get changed in the other instance as well. But just to ensure like we are not making a unnecessary change, like it shouldn't be something that got changed by mistake. So we have ensured that we return a totally new object. So this way we can protect the data from getting modified unnecessarily or by mistake when we are using these type of singleton patterns. And over here, the last one that I have is like reinitializing the entire settings. So we always have a default setting that I have set up in the code. So, but it might happen that configuration 1 just wants to reinitialize it with a totally different one. Over here, the theme has been changed, the language has been changed, new feature has been added. And now we can see like as soon as it got reinitialized, everything will be changing in configuration 2 at the same time. So this is a very practical example of the global configuration manager, how to implement singleton pattern in our code. So now I will try to get into the potential downsides of this singleton pattern. Because if you want an example with React, I will shortly come into it when we will be discussing the provider pattern. So I'm not repeating it twice over here. So let's go through the potential downfalls. So first potential downfall that we can see over here is that it becomes tightly coupled. So we always need to ensure what the global state is, and our components are so tightly coupled that sometimes it becomes very difficult to write unit tests, which is something very mandatorily we have to do. Also, something that important is that violation of single responsibility principle over here, along with the data being provided, like we have written the singleton class, or maybe I have written that configuration manager where we are returning an object that handles the data like get settings, set settings, initialize settings. But at the same time, it also need to manage that it is sending the same instance. So it's another job that it has to do within itself. So there is some violation over here. And another thing is like overuse. Like we also need to know when do we need to use singleton. It's not that everything is singleton. If we go that way, then our code will be very much tightly coupled and difficult to maintain. So first we need to identify if some property at all needs to be implemented with singleton or not, and then only we should go. Ideally, normally what the standard procedure follows is like if something is being repeated more than twice, it should go into a single response, singleton pattern, or else it's fine to repeat a code twice in the code base. So this is more or less that we have about the singleton pattern. And next to the singleton pattern is another one, which is something similar to this sort of pattern is the Mixin pattern. So according to the name as it suggests, so it's a reusable piece of code again that encapsulates certain specific functionalities. And the thing that happens is like it allows you to mix in behaviors. Like over here, behaviors are being mixed in between classes and objects, and it focuses on composition over inheritance. I will come deep into it shortly, and that how it is different between composition and inheritance. Also, with mixin, we need to know that it doesn't create a new type. It is like we are doing some encapsulation, we are creating composition on it, but we won't be creating a new type. We will just add some feature to the existing type. And this helps achieve code reuse and flexible, and mostly for JavaScript, because JavaScript primarily supports single inheritance. So I will come a bit more into it, like what is the problem that it solves that will help us understand like why we need this design pattern at the first place. So over here, what we do is like in single inheritance limitation that we have in JavaScript. So in JavaScript, like many languages, it allows only say a class to inherit from only one parent. We cannot add multiple inheritance in JavaScript. So deep inheritance hierarchies, when we cannot create and we try to forcefully create those things, it becomes very rigid, fragile, and fat class. Like you imagine you have class 1 that depends on class 2, or maybe just take the other ways. Like, imagine we are in class 5. So in class 5 is dependent on class 4 dependent on class 3 dependent on 2 and 1. So if anything changes in or any of these classes from class 4 to class 1, it will be very difficult to maintain it in the class 5. So, and this will need a lot of code to duplications, and that is something we need to think about. So what Mixin provides us is a hazard relationship. Like we are expanding the code horizontally and it's like, okay, we have some features. So before coming to when to use Mixin, I will try to go through the code base a bit so that we get to see what actually Mixin does. So over here again, I have created a class called person, and there's a constructor in this class that takes in the name of that person. And I have assumed over here that whoever is a person will be able to greet a person. So they all have a public method that greets. So now I have created two mixins out of this class. So these two mixins include the eater mixin and the docker mixin. So what over here I have done is like I have taken the base class as a parameter and have extended that base class. So over here the base class is, it can be anything, it doesn't have to be person all the time. Any base class that we take in as a parameter, we will just add a method on top of it called eat, and in the eater mixin. And if it is a talker mixin, then we will be adding two more methods on top of it, that is talk and whisper. And this way what we are doing, like it doesn't matter, like every eater mixin does not have to have a talker mixing feature. So we are just keeping everything separate. Next, finally, what I have tried to create is I've tried to create a human, and I want a human who can greet, who can eat, who can talk and whisper. So what over here I have done, first I have created the talker mixing, taking the person class as the base class over here. And then once that is done, that I have passed as a base class to my eater mixing. And over here, as you can see, the code is now extending horizontally. So this particular human has a method of its own, public method called introduce. And this method, what it does, it calls the greet method from the person class, and it calls the talk method from the talker mixing class. And over here, we can add any methods that is being extended from the eater mixing class at also at the same time. So over here, let's go to the console and let's see. So how this code has been going. So first I have created a human called Alice, and Alice can greet. So over here from the, as you can see over here, I have tried to put the class from which this greet method is being called. And over here, as you can see that Alice is being created from the person class. And then what Alice can eat as well. So Alice eats pizza. Alice can talk, can whisper, because we have seen like they are all the methods from the talker mixin and the eater mixin, that are the features that we have added inside the human. And finally, when Alice introduces, what does Alice do? Alice says like, okay, it greets. So yes, hello world, and then it whispers, and then it says, I am Alice and I am 30 years old. So over here, as you can see, this is the talk method that has been called. So over here, I can create another mixin at the same time. In this mixin, what I will be doing is like I have created a Bob, and Bob can eat and talk as well. Over here, because you know that when we have created human, we have created it from all these. Now, the only thing over here is like it is not mandatory that I always have to have both these methods to create a class. So I can just leave any one of it and then go without it. But in that case, I need to ensure that I don't need the features. So over here in practical example, if we if we come back to the scenario of when to use the mixins, over here, it's adding the utility behaviors. So it can be any utility behavior that a particular function needs. It can be can move feature, can serialize feature, can validate. So these are the ones that we can say with can. So when we are trying to add these type of behaviors, it's always better we put it use through mixins so that we don't burden the parent base class with these features also, because then again it will violate single responsibility principle. Also adding common features to classes which we don't control. So maybe how to log an error when we are using a third-party logger library. I don't need to bother about how the code has to be written. It might be maintained by someone else. So I will just hook that into my component and will start using. So these are has a relationship, right? Because when we are creating a class, we need a feature that can log, or we need a feature that can do some specific functionalities. Now, when we come to React in this scenario, over here, I'll go with the higher order components in React, which nowadays is not that popular because we have already started using hooks. But if you really have a code base with the legacy code of React, you will be seeing a lot of usage of this higher order components. So if you want to know what higher order component is actually in React, it is like you have a base component exactly similar to the base class that we created. And then on top of that base component, we will be adding some more features to that component and encapsulate it to a totally new component. So we won't be changing anything in the base component. It's just we will be adding some features to the base component and put it into a wrapper, and we will keep on using it. So that is what higher order components, where the concept of mixin has been used. But nowadays React suggests specially not to use mixin in the function components because they already have a hook and it becomes difficult to maintain also. Also composition, we have seen that it's a direct object compositions can also be done in this. It's an alternative approach of this one, but again, we can go with mixins. So now that we are done with mixins, we have the third design pattern, that is the provider pattern. I will try to run a bit because it's already, I have two more design patterns to cover. So I will try to be a bit faster. So what is the provider pattern if we talk about? So over here, it's very much related to the Singleton. As I mentioned during Singleton, I will talk about the React context thing once again. So provider pattern is where there is a design pattern focused on dependency injection and inversion of control. What it does, it centralizes our data or services that multiple parts of the applications need to use. It provides a single source from which the dependence components pool what they need, and it decouples the consumers from the producers. And we will go with the React context. Now, how is this provider pattern related to the Singleton? In Singleton, we said like we will be creating one instance. Over here in provider also, we will be creating one provider. And what similar to Singleton, what it does is that it will be creating one provider that will be storing all our instances, all our class value, the instance values of object or service and whatever. And then whoever needs those data, the consumers, will call the provider to fetch those data. And in case they need to update it, also they will be having reducer methods to update the data in the provider. So this is very much exactly what we do in the Singleton pattern as well. So they are very pretty similar. So over here, React Context API is what we are using for the example, but Redux, Justand, any state management library follows the same approach. Even if we don't follow any third-party libraries as well, we can create it with the subscriber and observer pattern over here as well in Angular, as we have seen earlier. So what is the problem that it solves? So the main problem that it solves with this provider pattern, where it works a bit different from Singleton, is the prop drilling. So in prop drilling, what will happen, like imagine there is a parent component and there is a child component. In between, we have maybe more 4 sibling components. So a data passes from the parent to the first sibling to the next, and in this way it proceeds on. This way, it makes the code verbose. It's a maintenance nightmare because in case one property value changes, we need to change all these components who have just passed on this data to the child component. It creates very tight coupling because always it's dependent on someone to receive the data. It depends on someone it needs to pass on the data. And that makes the code fat. So over here, as I mentioned just a bit before, like there is a provider that will be dedicated component or module that holds the data or the service, which provides the data or the service to the children, and they maintain the life cycle or the state value of that particular value over there. Then there's a consumer, any component or module that needs to access the data is or the service that we need is the access the consumer over here. It doesn't receive the data as a prop. We use the use context hook over here, or rather it subscribes to the provider and wait for any new update in the value that happens. And the value, which is the actual data, the state or the service instance that the provider makes it available. So when to use it, it's very common now. Like we have seen like in large applications where we have a lot of data to be passed across components, when we have the concept of dependency injections, when there is complex data structures and shared instances. So I will try to go through a practical code of this provider pattern and that will help me to explain it a bit easier. So over here, I have a React component. This is a app component that we have. And what I have done is like for the visibility of this, for this particular demo, I have created all the components in the same file so that it's easy to explain this one. Or else in ideally, we will having each of these components in several files. So one component is this maintain. It will be in a separate file from the section, and finally over here the use profile. But for the purpose of this demo, I have put it all in the same class. So over here we have this app component, that is the main component, and inside this main component we have the user, that is the current user. Over here I have named it Alice and it has an email as well. So what it has done is this main component, this has taken the current user, and then what it does, it has passed it to the section. So over here main content has taken the user as a parameter and passed it to the section. But you can see in the code, neither the main content nor the section content has no usage of that user. It does something totally different. What it is doing, it is just passing on that value. And what over here, finally, it has reached the last component, that is the user profile, that one, the one we are seeing over here in light blue. And over here, we are using the name and the email of that particular component, of that particular user. So over here, you have seen like over here, it's just 3 components, very small components. So it looks pretty simple, but just imagine each of these components are doing a lot of stuff, and just simply passing on the value of the user to its child is really a big mess. So what the other approach that we will be using over here is like this one. I will try to replace the content of this over here. Okay. So now in this React context example, we will be seeing how that value has changed. So first of all, I still have the main component that no longer passes any parameter to the section, because as we can see now they receive no user props. So that means no value is getting passed. Still we are able to see the user inside this user profile, the one that I have created over here in the main component, in the app component itself. So what I have done, I have wrapped this main component with a class called user provider, and inside that provider I have passed in my current user. So this user provider is now acting as the only provider, and whoever is within this user provider comes under this user provider, will any component can consume the value of this current user. So we will see how it does. So let's directly go to the first consumer that we have. The consumer is the user profile, the component in blue, who is the consumer, and we already have the provider at the top. So how does this consumer connect to that provider? For that, we have provided a custom hook called use user. So this use user will extract the value from the provider, and if it doesn't have any value, then it will show that, okay, I currently have no user data, but when it gets the value, it will update it with the user name and the user email. So this is the same code that we already have earlier. So there is no change in the user. It's only The thing is that the consumer is now using a custom hook to get the value from the provider. So now we will see how this provider is actually working. So for this, I have a class, this user context class. So while using this pattern, it's a bit verbose. We need to have some boilerplate code being created. So over here, as you can see, I have a user interface. Like my user always have a name and email. And I have a user context type. I'll come later on why we need this user context type. So first imagine over here, we need to create a context. So imagine we can take a very example of this the session that we are having today. So first the context was like that our volunteers from the Front-End Queens team have decided that they will be creating an event. So they are now creating a context of that event. So what are the properties inside that context? So first, the topic is design pattern. We need to figure out when these event will be organized. What are the design patterns that will be discussed in each of these sessions? Who will be the speakers? So with all this information, they have created a context. So now this context is what once we need to use this custom hook, or not the custom hook, the hook that is being provided by React called use context to create a context. And once that context get created, any of this information that the context has, whether it's a user in our scenario over here, or maybe in a front-end query example, we have taken the example where what event has been created, when is the date, who is the speaker, what is the topic. All these informations will be exposed through this context. And what it does is like over here, when we have created the actual provider, the provider method with which we wrapped our main component, inside that provider, we have passed on that context value. So at any point of time, any child component will get that response from this provider using that custom hook called use user, that, okay, when what is the current user that we have. Over here, I have only used the state value to create the user. We can have reducer methods over here that updates the user. So any child component can update the user at any point of time. So there is a bit of boilerplate code that we need to write, but it's quite simple and it's the same across all applications that we have. So over here, as you can see, like currently, without even passing the data through the main content or the section details, it is being consumed by the user profile directly from the app component where it has been set. So when to use it? So coming back to the slides, as we have seen, it is being used always for the global or the app-wide state. Shared services, we might need to, now I have, in the example, I have shown only user. We might have services as well, that instances of services that needs to be shared. Dependency injections, large applications, these are all the common use cases where we need it. And now there's a rule of thumb for creating this context as well. So similar to singleton pattern, everything doesn't need to be in a context. So if normally the rule that we follow is that if a same prop has been passed on more than 3 level of child components, better we put it into a provider. So not for every component that we need, every one time we need to pass a data, we don't need a context for it, because again, this context makes the code a bit heavy at the same time. So we also need to figure out when to use it. And now I'll come to the last design pattern of the day that we have, that is the static import. It's static import as the topic, but we will be following both the static and the dynamic import over here. Static import is the most common way we import modules in JavaScript and TypeScript. So it's the same way that we write at the top, import something from a module specifier. And we resolve at parse and compile time. So the dependencies are being analyzed when the code is being run from top to bottom. There's a pattern of synchronous loading conceptually, because when the code is being running from top to bottom, we first go line by line. But again, we need to remember the time that it takes to get the value of that entire import. It is not same. So the code will not wait for it. It will just start parsing the next one. And the top level only. So when it is static import, we always have to put it at the top. So I'll get into the next one to explain how it works. So if we see any normal example that we have, like over here, we are having these many imports. So what happens as soon as this file gets rendered, it starts reading all the imports one by one. And it also tries to figure out that if there is any cyclic dependency that has got created. So we need to be very careful when we are using these imports. So these imports can be from third-party libraries, like over here you can see React, so it will refer to the node modules to fetch the use state. If it is from something like this index.css, which is within the code, or something like get greeting, it is also within the code. So it will try to load them one by one. So next is the resolution. So it's resolved to a concrete file path. So the module specifiers like this one .utils or React or Lodash, they resolve to a concrete file path. Node.js, anything that is not within the folder structure, it will refer to the node modules and the package.json for the resolutions. And one thing that we need to keep in mind over here is like, especially when it is coming from Node.js, this will be running only once. So whatever is the instance over there will only be fetched and only be referred to. Any update in this use state later on, like after it got loaded, will not be taken into consideration. So this is how this static import works. Now there are certain implications and design considerations. Like initially it looks very simple, like, okay, these are the same basic imports that we write, but something we need to really take care of. One is the initial load performance. So first of all, we always, in production, when we see in enterprise level code, we see there's a huge list of imports. So we always need to keep in mind we should load only the things that's necessary, because the code base will, the website will totally wait until all this parsing happens. It will not make it interactive at all. So we need to ensure that we give as much as import as possible so that it immediately loads it and makes the website interactive. So over here, there is a concept called code splitting, where we come with dynamic imports. Like if we don't need a certain module at the load time, then let's put it later. We don't need to load it at the time when the website is rendering for the first time. That is called the eagle loading. So everything imported statically is loaded, even if it's not immediately needed by the current user interaction. So that's why let's not make it heavy at the initial phase itself. Another thing is static imports cannot be used conditionally. Whatever is there will have to get loaded. If we really need conditional loading, like there is a scenario when I want to load a certain component or a certain library, there is a scenario when I don't want to load it, then let's follow the dynamic imports over here. So I'll jump into the code quickly to show an example over here, like how it works. So over here, as you can see, I have two examples. One is the static import and one is the dynamic import example. So in the static import, what has happened is like whatever the file has been rendered from read from top to bottom, and this static import content has got rendered. So I will just clean it and try to rerun it once again. Yes. So you can see that module has been evaluated. The static imports has been taken into care. So these were my static imports. Now I have a section called a dynamic import, and there is a heavy computation that will be executing when I click this particular button. And over here, as you can see, every time when this page is rendered, user might not click this button. So it will be very unnecessary if I load the content of this particular button, whatever it needs for this button to run over here. So in load compute, heavy computation, what I have over here is like the dynamic import. So if a user clicks on this button, I will import a separate module that involves the heavy computation, and based on that, I will be running the code. So now only when I have clicked on this button, you can see that this heavy dynamic import has been made successful, and this import has happened. This import initially didn't happen when I have run the page for the first time. So this way, this actually impacts a lot, because first, when we create a website, the first thing that we measure is the performance. And in this performance, the time for the first interaction is always important. So whenever we are using this type of libraries, be it React or be it Angular or whatever front-end framework we are using, we always need to be very careful about the bundle size. because a change in the KB will also impact the time for its first interaction. So that's why we always refer like the first bundle that loads in the browser has to be the lightest one. So that's why this particular design pattern is very important. Like we need to load only what is necessary and when it is necessary, or else for the other things we can keep it on hold. So this that was actually the 4 design patterns that I had. So all the code that I have shown from the code sandbox, they are already there in the design pattern GitHub, the repository. I will be sharing this slide with you shortly. And over here, I have also tried to add the links for the YouTube links of the other design pattern sessions that we already had. And yes, that is what all I had to share for today.
All right. Thank you so much, Poulami. That was great. I have to look into a couple of those for my work. That was fantastic. Thank you so much. I'm going to share my screen just in case anyone has any questions. Feel free to chat. Yeah.
I don't have a question. I just want to thank Poulami for this session. Very instructive as always. I love when you're the speaker because, yeah, the theoretical part, the pros and cons, yeah, it's all brilliant. Thank you.